Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra. This is lesson 7.3 on the special products of polynomials, wherein we ask the essential question, what are the patterns of special products? And you can see those right here. The first one is the product of a sum and a difference of the same two, I'm going to call them terms, but the same two values, okay? The second, this is the square of a sum, right? The square of a sum and the square of a difference. We're going to look at each of these in detail. So first thing we want to look at, this idea of squaring. Now, you'll notice over here I've got 36 little squares in one big square. Have you ever wondered why we call numbers like 36 perfect squares? Well, because those numbers can be put into a square. Like I've got 36 little squares, I can put them into one big square. So I have 6 by 6. 6 times 6 equals 6 squared equals 36. What about over here? This is a square, but it's not the little squares here. It's something different. But what's important to know here is that I have the same length here as I do here. So let's call this x. We don't know what this is. And let's call this, 1. Let's call this distance 1. And this is x, and this is 1. Okay. Well, this little square here would be x times x, right? Because this is x times x, so that's x squared. This larger rectangle over here would be x times 1, right? This is the length x, this is the length 1. 1 times x is x. This rectangle down here, also x, the length x, times the length 1, x. So the area, x times 1, x. This little square has a side length of 1 and a height of 1. So 1 times 1 is 1. So this is x squared plus x plus 1. Again, I'm multiplying two binomials, so I have 4 partial products. And if I simplify my terms here, I have x squared plus 2x plus 1. This type of trinomial we call a perfect square trinomial. Okay, so let's go ahead and look at some concepts here. The first is a square of a binomial. So this is the one I just did here, where we're squaring a, let me go back here just to show you what we're doing here. This is x plus 1. Each side is x plus 1, so, right? So x plus 1 times x plus 1. So we're squaring a binomial, and we get what's called a perfect square trinomial, because it's a trinomial and it's a perfect square, just like 36 is a perfect square. Okay, so this is the one that I just kind of demonstrated by using x and 1. They're using all variables, of course, because they're trying to just set up a pattern here. And this is the square of a difference. And so what's the difference here? So what are we looking at? Well, to be a perfect square trinomial, we have a square. We square the first item, right? And we square the last item, and then we multiply these two things together, and then double it times 2. We double whatever this product of the a and the b are. We double it. For the difference, it's the same, except this middle term is going to be negative. The middle term is negative, otherwise it's the same. So in these examples over here, x plus 5, the whole thing squared. My shortcut for this is going to be, I take the first term, I square it, x squared. I take 5 times x, or x times 5. 5 times x is 5x times 2. 5x times 2, 10x. And then 5 times 5, 25. And it's the same for the difference, except this middle term is going to come out to be negative, right? The middle term will come out to be negative. Okay, so let's do a couple examples here. I've got 3x plus 4, quantity squared. Okay, my first term squared. 3x times 3x is 9x squared. Plus 3x times 4. 3 times 4 is 12. 12x doubled. 12x doubled. 24x. Plus 4 squared is 16. This last term is always positive. This last term will always be some kind of square as well. Okay, and then b, 5x squared would be, 5x quantity squared, 5x times 5x, 25x squared, minus, we know if this is a minus, this middle term would be negative, 5x times 2y, 10xy, doubled, 20xy, plus, last one's always positive, 2y, whole thing squared, 4y squared. So you'll notice that the first and the last terms are always perfect squares. 9x squared, 16, 25x squared, 4y squared. Okay? The whole thing is a perfect square. Okay, so let's look at when we multiply what we call the sum and the difference. So here we have a plus b times a minus b. And let's see what's going to happen if I do that. I'm going to do this the long way first. So a times a is a squared. A times negative b would be negative ab. B times a would be positive ab. And then b times negative b would be negative b squared. Okay, well, look what happens when we do that. These two middle terms cancel out. And that's going to happen every time. Negative ab plus ab equals 0. They cancel each other out, which just leaves us the a squared minus b squared. And this is, it's always going to be this pattern here, a squared minus b squared. This is a minus. And we call this, this result here, we call the difference of two squares. This result is called the difference of two squares, because it's a square minus a square. Difference of two squares. Let's try some examples here. Okay, so the first example, t plus 5 times t plus 5 times t minus 5. I'm taking the shortcut. This is going to be t squared minus 25. Right? The first item squared minus the second item squared. Easy. The second example, 3x plus y times 3x minus y. The sum and the difference are the same too. I can take the shortcut. 9x squared minus y squared. Easy. Shortcut on that one is super easy. Let's see. Special products and mental math. We want to use special product patterns to find the product of 26 times 34. Well, I'm not sure how easy this is going to be to do mentally, but here's how you can think of a problem like this. You can think of 26 as 30 minus 4, and 34 is 30 plus 4. And again, this is only going to work for certain problems, right? Only going to work for certain where each of your numbers is a certain distance from, in this case, 30, right? This one's 4 less than 30. This one's 4 more than 30. But since it's 30 minus 4 times 30 plus 4, I can think of this as 30 times 30. I can think of this as 900 minus 16. So I can think of this as 884. I don't know if this is a useful skill or not, but you might find this is in the book, so we're going to talk about it. That's it for now. We will see you in class next time, and have a good rest of your day. Bye-bye.